Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistance, and today we're looking at limiting reagents. So we're given a balanced equation and the mass of both of the reactants. And from there we can do several things. I'm going to do three things today. They sound intimidating, but they're relatively easy. We're going to determine which of the reactants is the limiting reagent. And from there, we're going to find the mass of one of the products. It can be either one. I'm going to choose CO2. And then we're going to find out the excess left over by the non-limiting reagent reactant. Okay, so let's get started. We're going to start by determining which is the limiting reagent. We're given the mass of oxygen and the mass of ethane. So from there, we need to look at how we can determine which would be the limiting reagent. And the easiest and only way that you can is by comparing the moles. The least number of moles wins out because that is the reactant that will be consumed entirely first. And that is what the limiting reagent is. It means if you had an excess of one, the other would be the limiting reagent. Whichever reactant runs out first is the determining factor of when the reaction ends. So we're going to determine between the two reactants which one is the limiting reagent. So let's start off with oxygen here. We're going to take the mass that we're given, which is 736.2 grams, and we're going to convert it to moles. And we're not just going to convert it to moles, we're going to convert it to the moles of one of the products. You could choose either product. Again, I'm going to choose CO2 today, but I could just as easily have chosen water. And the idea being that you don't want to switch from one to the other. So you choose a product and you stick with it regardless. So converting this to moles, you just use the molar mass of oxygen, which is 1 mole over 32.00 grams. I'm assuming at this point that you can calculate the molecular mass of a molecule. And then you have to do its molar relation to find out how many moles of the product that you chose this actually would result in. So in this case, I'm choosing CO2. So the moles that I've already written out are moles of diatomic oxygen. So for 7 moles of O2, we have 4 moles of CO2, which results in 13.15 moles of CO2. So what this equation, this dimensional analysis is telling us is that if you had an excess of ethane and you just had the 736.2 grams of oxygen, you could run this reaction until you have 13.15 moles of CO2, at which point the reaction would stop because all of the oxygen would have been consumed in the reaction. Let's do the same thing with ethane. So we're given 2,141 grams of ethane, and then we're going to divide it by its molar mass, which is the same as multiplying it by 1 mole over its gram equivalent for the molecular mass. So in this case, it's 30.07 grams. Again, assuming you can go ahead and do the addition and multiplication to get the molecular mass. And then its molar relation with CO2, 4 moles CO2 and versus 2 moles of ethane. Okay, and that would yield 142.4 moles of CO2. So what that's saying is that if we had an unlimited supply of oxygen, but we had that limited supply of ethane, that we could burn the ethane to the point of getting 142.4 moles of CO2, at which point we will have run out of the ethane, and we would at that point need to, the reaction would stop. So we can determine from this that if we were to look at the total number of moles, 13.5 is far less than 142.4, meaning that we're going to run out of oxygen before we run out of ethane. Therefore, O2 is our limiting reagent for this reaction. So let's say from here you want to find out how much CO2 is formed in its mass. All you'd have to do is take 13.15, that's for this whole equation. This whole equation is only going to make 13.15 moles of CO2 given the mass of oxygen. And you just simply multiply it by its molar mass, which CO2's molar mass is 44.01 grams per mole. And I just write it like that, 44.01 grams over 1 mole, which gets us 578.7 grams of CO2. So that's how much CO2, the mass of the CO2 that would have been produced by this reaction, given the masses of the reactants that we have. So there's one other thing that you can determine from this, and that is the excess or leftover reagent. So we know that all of the oxygen gets consumed, but what about this little bit of ethane that should be left? So to determine that, we'll simply, let's use a different color. To determine that, you simply take the moles of CO2 and you again use the molar relation between CO2 and ethane, which would be 2 moles over 4 moles, which you can reduce to 1 over 2, times the molar mass of ethane, and that will get you 790.8 grams. That's the amount of ethane that is consumed. So from there, we simply take the total amount of ethane, 2,141 grams, and subtract the 790.8 grams, and we are left with 1,350.2, but because we're using significant figures and the least number of digits following a decimal is 0, we're going to leave it at 1,350 grams. And that is our excess that was not consumed in the reaction.